Hi everyone. This is the second class of our practice for the TA class on Wednesday, and um, we are dealing with the second file that I uploaded in the learners. So you can download the second file on your laptop and open the file and do the same thing with me. So I heard that you learned about the after actually we learned about the visualizing thing in our practice by downloading our own CSV file. And the next thing is that we are going to do the numerical descriptive statistics, in which there are a lot of statistics things like mean, median, mode, variance, standard deviation, interquartile range, or and correlation coefficient. So there are a lot of numerical measures thing, and we are going to do the R practice step by step. So actually there are three kind of the statistics, numerical statistics. So the first is that we are going to deal with a central location. The next thing is that the variability of our data, and third is that the association of the two data. So the first is that we are going to deal with a measure of central location, and as I already know, actually this is very common knowledge, which is a mean or median or mode. And as you already know and learn about this notion, I think what you have to do is just following the step, following or just realizing the mathematical formula for mean or median or mode. So as you already know, this is the formula for population or sample mean, which is the same to each other. So if we have a 5 data, 5 number, we can get the population or sample mean, which is the central location of our data. So actually you can refer to the R file because I prepared the same data with this the class material PDF file. So the number are same here, as you can see. And if I can teach one more thing in our programming language, if we want to, if we want to get the variable a, which has a value as a 5, we can do the our programming language with this code, because this is a assignment operator in which we can store the value 5 into our own variable a. In the same sense, we can also store our vector into our own variable whose name is ex1 in this case. And it is important that we are going to store 5 values in one variable by using vector. So we can use vector with C sign here. So in this parenthesis, we can make 5 values in one variable. So this is how we use the vector sign here. So you can see that in this below panel, you can see that we have variable ex1, which has 5 values, as we already did here. So because this is the mean formula with the mean mathematical formula, we can do the same thing. So we can sum up with all the values and divide it by the number of the sample, which is the 5. And the result is the 15. And there are 4 kinds of how we get the expectation value actually. I mean mean value. So the second is that we can also use the sum function and divide it also by the number of the sample. which is the 5. And you can see that we can also get the same result from the previous thing. And there is also even the min function in R programming, which gives us the mean value of our data. So if we put our vector here in min function, we can get the mean value directly, which is very easy. And we can also get the mean value by dividing our summation value with the length of our data. And as you can already know, length function gives us the number of the sample. So you can see that the result of the length function is 5 because we have a 5 value in variable ex1. So this is how we get the mean value from R programming, and you can see that there are a lot of ways to get the mean value. And there is also median thing. So median can give us the center location also, as well as the mean value, and it usually not affected by the outlier, which is very large number or very small number. Maybe the outlier is very far away from our center location, so if we get the mean, it is very large, which is affected by the outlier, but by using the median, we can get the center location more more intuitively. So this is how we get the median value in our programming. So even if we have a outlier here, which is 200,000, you can see that mean value is very large because of the outlier. However, if we use the sort function, we can get the sorted result of our vectors. So you can say that this is the programming language. So with this code options function, we can get the mathematical number, which we can see very intuitively, very directly. So let's run the code again. So you can see that this is our original vector, which has 8 value. And with the sort function, we can get the sorted value, which is very easy. And because our programming already gives us the median function, we can already get the median value, which is 6, which can explain the central location of our variable ex2 more rightly, yeah. And we can get also the median value by using the quantile function with the probability as 0.5 because I believe in that you already know what quantile is, and quantile value with the probability as 0.5 is same as the median value. So we can also get the median value by using the quantile function, actually, which has the same result from previous thing. And there is also mode, which can explain also the central location of our data. And we just want to get the most frequent value in our data, which is 1 in this case. For our this data, I prepared the same data here. So with the table function and the which max function, we can get the value which occurred very most oftenly. So we can get the mode value with this kind of function. And I think that you don't have to know what this function is and what this function is used for very deeply, but what you have to know is that this is the functions for getting the mode value. Yeah, so whenever we put our own data in this function, we can always get the mode value. This is the important thing here. And we are done with the central location. And the second thing is that we also have to know the variability of our data, because even though we know the central location, we cannot fully explain what our data is and how our data is distributed. So we also have to know the variability of the data with these four kinds of the notion, which is range or variance and interquartile range, and even the coefficient of variation. So let's do the step by step. Let's do it step by step. And the first thing is the range, which is the difference between maximum value and the minimum value, which is very easy. And as you already know, we can get the maximum and minimum value with the max and min function in our programming. So we can get the range and maximum and minimum value of our data very easily. And there is also the range function itself. So range function gives us the maximum and minimum value of our data. We can get the range itself by using the difference function, as the input is the result of the range function. So we can get the result as 8, which is same as the previous result. And the most important thing and most famous thing is the variance, and as well as the standard deviation. And as you already know, variance is variance measures how far a set of numbers is spread out. So we can use this formula for getting the variance. And I think the most important thing is that you have to classify our data is from population or sample, because it depends on the formula. It depends on where the sample comes from. So if the sample comes from the population, we have to use this formula from the left side. And if the sample our data comes from the sample, we have to use the sample variance and follow the right side formula, which is different from each other. So the most important thing is that we have to divide the number of sample. Yeah, it is different from each other. So you always have to know where those data comes from between population or sample. So let's say that we have these 5 data here, 5 values in our data. And yeah, so I prepared the same data here with the vector sign. So actually, this is the two ways of the formula or our code for getting the variance. So this is the division, and we power it the division. So if you get the result of division, you can get the 5 value, because our programming gives us the each result from deducting the mean, deducting our own data from our own mean values. So because we already have 5 values in our data, for our division, we also have the 5 values for our own each division. So if you even scale it or even power it, we can also get the 5 values, because it is also scaled, from each value. And because this is the population variance formula, we can use this formula, and if you run this code, you can get that the population variance as about 11.6. And if our data comes from the sample, we follow the formula for sample variance, which is the we divide the same value with the n minus 1. So which is the result is 14.5, which is different from each other. And there is also actually the variance function in R programming. So with the VAR function, which is the variance function, we can get the 14.5. So the most important thing is that we get, if we use the variance function in our programming, it gives us the sample variance, not the population variance. So if we are dealing with the sample as our data, we can always use variance function because it gives us the sample variance. However, if our data is about population, we cannot use variance function because it gives us the sample variance, not population variance. So in that case, we have to get the population variance by our own hand, mathematically, or in our programming. So you always have to notice that our data comes from each group, population or sample, which is very important. And there is also standard deviation, which is nothing but just the square root of our own variance. So because we have two kind of variance here, we also have two kind of standard deviation, which is the sample standard deviation or population standard deviation. And I think I didn't explain about what this operator, and this is just about power function. So if we want to get the sorry about the interruption. So if we want to get the power of number 2, we can use this operator sign, and you can get the result of the power thing. So for your understanding, I just explained what this operator means. And because we are dealing with a standard deviation, what you have to do is just get the square root value of our variance. So what you have to do is just to use the square root function here, which is SQRT. And for the population standard deviation, we use the square root, get the square root value of the population variance that we already stored in here in this line. And if we want to get the sample standard deviation, we have to get the value result from the square root of the sample variance that we stored in this line here. And there is also a standard deviation function itself in our programming. So with the ST, which is the standard deviation function, we can get the sample standard deviation, not the population standard deviation. So if we are dealing with the sample data, it is okay to use the standard deviation function or variance function in our programming. However, again, if we are dealing with the population data, we never use the variance or standard deviation function because it gives us the different value from the answer. So be careful of that. And the third thing is that we can also get the quantile value. And I heard that Professor Park is about to teach you about quantile or interquartile range in R programming also. And there will be also another R video lecture there. So I will briefly skip this part. So you can also learn what is quantile and interquartile range in R programming in another video from Professor Park. What you have to know in this part is actually is that if we have our own data, contail function always gives us the contail value as a input, as they put our own probabilities here. So with these contail values, we can also get the interquartile range, which is the IQR, as you already know, which is the third quartile from the difference between third quartile and the first quartile, which is here. Yeah, maybe it is in this part. Yeah, IQR is the difference between these two values, and we can get these two values with this quantile function. So yeah, more thing will be in the Professor Park's video, so I will skip this part briefly. And the first thing is that it is the coefficient of variation, and actually this is not that famous statistics in our world, but I believe in that this also gives us the information for the measure of variability of our data. So we can also get the CV, which is the coefficient of variation, by dividing our standard deviation with the mean here. So actually, we know the mean function and we know the standard deviation function. We can get each value of the coefficient of variation by using the two function here and dividing one value by the other value, so which is very easy. And let me just run all the code here, and you can get the coefficient of variation in percent value here. And the last thing is that the measure of association. So as I already have done, we already have done in last class about scatter plot, where we can see the two relationship between two data. So it also gives us the measure of association, and because we have the, let's say that we have a two data here, so we want to get the measure of association between each two pair. The first thing is that x between x and y1, and the second is that between x and y2. So I store the three data here, and in x and y1 and y2 value, and let's visualize it as we already did in the last class. So if you see the value here, you can get that the two data between x and y1 has very strong positive relationship between each other. And actually you can also see that if you already run the second code plotting the two data here, you can also get the same shape for the data, because this is just showing the measure of association. However, we can just make it comparatively by using the covariance statistics. So covariance gives us the measure of the joint variability of two random variables. So it reflects actually scale of two data. So by using this formula, we can get the covariance function here. So actually, this is the mathematical formula, and if we realize this formula in our while programming, it is same as this code. And if you get this, oh sorry, this is y1 here and y2 here. So please modify the code here. So if you get the covariance here, you can get that the covariance between x and y1 is 25 here. And let's do the second code. Let's run the second code, which is maybe the covariance between x and y2. And y2 covariance between x and y2 is about 2500, which is much larger than the burst covariance, because we can see that because covariance reflects the scale of the data, and because y2 is more larger than y1, the covariance between x and y2 is much larger than the covariance between x and y1, because covariance gives us the gives us the scale of the values as well as the measurable association. So you have to know about this one. And actually, there is also covariance function itself in our programming, so we can very easily get the covariance value here with using the covariance function. And as you already know, the correlation coefficient is so we can get correlation coefficient, the next notion, by dividing our covariance with each standard deviation. So we can get the correlation coefficient by dividing the same thing here. So divide the covariance with the multiplication of our standard deviation of each data here. So after getting the covariance of each value, you can see that the standard deviation, the correlation coefficient is 1 actually. So even though we see the correlation coefficient between x and y1, or even though we see the correlation coefficient between x and y2, we always get the same value, because we can normalize the covariance, so it doesn't reflect the scale of each data anymore in the correlation coefficient thing. So we can always see only the how it is associated with each other, not the scale of the two data. And there is also the correlation function here. So you can see that it also gives us the same result here. So to sum of it, we just learn about the various kind of notion dealing with numerical statistics, and there is also example number 5. So we can use the scalar plot or correlation coefficient between two data here. So we can calculate the sample covariance by, after storing each data in our own variable, temperature and ice, we can also plot the two data scalar plot, and you can also get the correlation of coefficient very easily by using the correlation function, which is about 0.88. And we can also use the mathematical formula by using the covariance function and standard deviation function, which has the same result from previous thing. So this is the end of the second class, and thank you.